Hey Dad, hey Mom.
Hey Robbie. What are you doing?
Playing the game.
Finish your homework yet?
No, I got stuck on this frame problem in statics. I just don't get it.
Oh, we can help you with that.
Oh, awesome. That'd be very, very helpful. Okay, so this is the homework problem I have to do. So for this problem, we have to find the support reactions at A, B, C, D, and E when the weight weighs 80 pounds.
In order to solve this problem, we need to start by drawing the reactions at supports E, A, and D, and the weight of the block. For support E, we have reactions in the X and Y directions. For support A, we only have a force in the X direction.
Why is it just in the X direction?
Because the support isn't pinned, so it's not keeping it from moving in the Y directions. And the weight of the block is acting down.
Wait, why is the support reaction at D diagonal?
Our DC is pin-pinned with no outside forces or moments acting along the bar. The resultant forces of pins D and C must be equal, opposite, and collinear.
So this is a system free body diagram?
Yeah, now we have to draw the free body diagrams for each of the separate parts. This is the free body diagram for part EB. The tension in this rope due to the frictionless weightless pulley is equal to the weight of the block, which is 80 pounds. The support reactions at E we already know from the system free body diagram, which are EX and EY. And now that joint B is exposed, we need to draw the reactions at this support as well, which are BX and BY. This is the free body diagram for part ABC. The tension in the rope is again equal to the weight of the block, which is 80 pounds. The reaction at joint C is equal and opposite to the reaction in the free body diagram DC. And the same for B. The reactions are equal and opposite to those in the free body diagram EB. And we already know the support reactions at A from the system free body diagram.
First, we're going to start by using free body diagram of bar ABC to solve for BY by taking a moment around C. We take a moment around C because we can eliminate force FDC, BX, and AX. So first we take BY. It acts negatively around point C, and we times it by its distance, which is 3 feet. We take 80 pounds, times it by its distance of 1 foot, and also the downward force of 80 times its distance from C, which is 2 feet. After solving for BY, we get negative 26.7 pounds in the negative direction as drawn. Since we know force BY, we can now take the sum of the forces in the Y direction by adding force BY, the vertical component of force FDC, and the weight of the block acting in the negative direction. So we get FDC equals 192.3 pounds.
Because we already know the force of By, we can use free body diagram EB to find out the force of Bx by taking the moments around point E. When taking the moments around point E, forces Ex and Ey do not factor into the equation because they pass through point E. First we take the force of 80 pounds from the rope and multiply it by its perpendicular distance of 2 feet. We then subtract Bx times its perpendicular distance of 4 feet. And finally subtract By times its perpendicular distance of 3 feet. By substituting in By, which is equal to 26.7 pounds, and solving for Bx, we find out that Bx is equal to 80 pounds. We can also use the value of By to solve for the value of Ey by summing the forces in the y direction of free body diagram EB. First we start by subtracting By and adding Ey and setting them equal to 0. By substituting in By and solving for Ey, we find that Ey is equal to negative 26.7 pounds.
Okay, so I get it now. So now we can start and find the forces in the x direction to solve for Ex, since we know that Bx is equal to 80 pounds from the previous force body diagram. So we have that Ex minus Bx, which is 80 pounds, plus 80 pounds, which is the weight in the string from the block, and set it equal to 0. And then Ex then equals 0 pounds. So now we can go back to the force body diagram ABC to solve for Ax using some of the forces in the x direction. So we have Ax plus Bx plus the x component of force DC minus the 80 pounds from the force and the tension. You can set it equal to 0. Since we already know that Bx is equal to 80 pounds and FDC is equal to 192.3 pounds, we find that Ax is equal to negative 160 pounds. And this is the weight in all the support reactions in the free body diagram. Oh, so that's how you solve the problem? Well, that was easy. I'll see you guys later. I'm going to the mall.
Have fun.
Be safe.